Hey students, in this video we're going to be going through the guided notes for section 5.3, which is called Properties of Addition and Multiplication. So my suggestion would be to print out the blank copy of the guided notes if you can, and then fill them in by watching this video and looking at the filled in copy posted to Google Classroom. So, in this video, we're going to talk about two different properties of addition and multiplication. The first is called the commutative property. The commutative property tells us that changing the order of our numbers, doesn't change the answer. Now, this isn't true all the time. This is only true for addition and multiplication. So when I add or multiply numbers, changing the order does not change the answer. Let me show you a few examples. If I add 5 and 4, 5 plus 4 equals 9. If I were to change the order and do 5 plus 4 instead, I changed the order, 5 plus 4 is still just 9. Changing the order of my added numbers didn't change the answer. This is also true for multiplication. So if I do 2 times 3, 2 times 3 makes 6. If I change the order and write 3 times 2 instead, 3 times 2 is still just 6. So again, when I changed the order in my multiplication problem, my answer did not change either. So the commutative property tells us that we can change the order of our numbers and it doesn't change the answer. This is only true for addition and multiplication. This does not work for subtraction or division. The way I like to remember the commutative property is I think about commuting to and from work. When someone commutes to and from work, that means they drive to work and then they drive back in the opposite direction. They're changing the order. So commutative property, you commute to and from work. Changing the order does not change the answer, right? If you drive to and from work, it's the same distance both ways, even if you're going in a different order, in a different direction. The next property we're going to talk about is called the associative property. The associative property says that changing the grouping of your numbers doesn't change the answer. Again, this is only true for addition and multiplication. So when I'm adding or multiplying numbers, changing the grouping does not change the answer. So our first example here, it's going to be 3 plus 4 in parentheses plus 2. So if I evaluate this using GEMDAS, I would do the grouping symbols first. 3 plus 4 would be 7, and then 7 plus 2, I would get 9. Now let's change the grouping. Let's pick those parentheses up and shift them over so that they are surrounding the 4 plus 2 instead. I just picked them up and moved them over. Again, I would need to evaluate grouping symbols first. 4 plus 2 is 6. 3 plus 6, I still get 9. So even though I changed where the grouping symbols were, even though I picked them up and moved them, my answer did not change. Now let's do a multiplication example. If I have 2 times 4 in a group times 5, I would have to evaluate grouping symbols first. 2 times 4 is 8. 8 times 5 is 40. Now let's change the grouping. Let's pick those grouping symbols up, move them over, and put them back down around the 4 and 5 instead. So this time it's 2 times 4 times 5 in a group. We shifted those over to be around the 4 times 5. I would evaluate grouping symbols first. 4 times 5 is 20, and then 2 times 20 is 40. So even though I changed where the grouping symbols were, I still got the same answer. So the associative property says you can change where the grouping symbols are, and it does not change the answer. Again, this is only true for addition and multiplication. It doesn't work for subtraction or division. The way I remember the associative property is thinking about the people you associate with. You might associate with different groups, but that doesn't mean the people are different. The people there are still going to be the same, right? So even if you associate with different groups, if you change the grouping, our answer is still the same. So the associative property says you can change the grouping, you can associate with different groups, and it doesn't change the answer. This is only true for addition and multiplication. So now we're going to talk about how we can actually use this to be helpful. The main way we use the associative and commutative properties is to write equivalent expressions or to simplify expressions. To take something like this, 7 plus 12 plus x in parentheses, and make it a little bit shorter. So when you look at this, you might notice that there's a 7 and a 12, 7 plus 12. We know how to add that together. We know how to add 7 plus 12. I might not be able to add the x to it right now because I don't know what x equals, but I can definitely add the 7 and the 12. But look, they're not in the same group right now, so I can't actually add them together. But I could use my properties of addition to get them together in the same group. So that's our goal when we're doing this, when we're writing an equivalent expression or simplifying an expression. We're looking at those things that are alike, the 7 and the 12, the whole numbers, the ones we know how to add together, and we're trying to get them together in the same group to make this a little bit simpler. So I want these together in the same group. They're already next to each other. So I'm just going to pick those parentheses up, shift them over, and put them back down around the 7 plus 12. I just shifted the grouping. And again, I'm allowed to do that because of the associative property. The associative property says, hey, you can change the grouping when you're adding numbers. I'm adding all these numbers, so I can just shift those grouping symbols over, and my answer is not going to change. Now that they're in the same group, I can actually add them together. 7 plus 12 makes 19. Now my expression looks like this, 19 plus x. We took something that was a little bit longer and we shortened it up. We found those whole numbers and we got them together in the same group so that we could combine them. Let's try another one. We have 6 plus x plus 8. So again, just like last time, I see two whole numbers, 6 and 8. I know how to add 6 and 8 together, but to be able to do that, they need to be together in the same group. So I'm going to use my properties of addition to make that happen. First thing I notice is that 6 is not next to 8. It does need to be next to 8. So I'm going to use my commutative property to switch the order of the 6 and the x. When I add things together, I can change the order according to the commutative property. So I'm going to switch that x and 6. That way 6 and 8 are a little closer together. They're still not in the same group though, so I do need to pick up the grouping symbols and move them over to be around the 6 plus 8. I can do that because of the associative property. That tells me, hey, if you're adding stuff together, you can change the grouping. Now that they're together in the same group, we can go ahead and add them together. 6 plus 8 is 14. So my simplified expression here is x plus 14. I took this thing that's a bit longer and made it a little shorter using these properties. All right, question 3. This one says 5 times 11y. Remember, 11y means 11 times y. If it's more helpful to you, you can add these multiplication symbols in so you don't forget. These are all multiplied together. 5 times 11 times y. So I see a 5 and I see an 11. Even though this isn't addition and it's multiplication, I still know how to multiply those together. I know how to multiply 5 and 11. But in order to do that, they need to be together in the same group. So I'm going to use my properties of multiplication to make that happen. The 5 times 11 is already next to each other, but I need the grouping symbols to be around that. So I'm going to pick them up and shift them over around the 5 times 11. I can do that because of the associative property. That tells me I can change the grouping and it does not change my answer when I am multiplying numbers. 5 times 11 is 55. So now I have 55 times y, or we could just write 55y. This is our simplified expression. We got those whole numbers together in the same group to make this just a little bit shorter. All right, example 4. This says 9 times 0 times p. So this one is actually going to be using a property that we haven't talked about before, but it's something that I think most of us already know. Let's look at this first part, 9 times 0. What's 9 times 0? Well, whatever this other number is, even if it's not 9, anything times 0 is just 0. 9 times 0 is 0. Now it says 0 times p. What's 0 times p? Well, again, anything times 0 is just 0. So 9 times 0 times p, that's just 0. That concept, the idea that when you multiply something by 0, it is 0, that is called the multiplication property of 0. Multiplying anything by 0 results in 0. So again, that's something I think a lot of us already know. Multiplying something by 0 equals 0, but it actually has a name, the multiplication property of 0. So if you have a bunch of stuff multiplied by 0, it's all just going to equal 0. All right, example 5, we have 4 times r times 1. So you might be tempted to, like in the previous examples, get the 4 and the 1 together in the same group. And we could do that. We could switch r and 1, put grouping symbols around 4 and 1. We could do all of that. But do we really need to? We actually don't, because anytime I multiply something by 1, like right here, r times 1, it is always just going to be that other number. Anything times 1 is just itself. R times 1 is just r. That gives us 4 times r, which is just 4r. So anytime we multiply something by 1, the answer is just itself. Anything times 1 is itself. So that's something we may have already known, that when you multiply a number by 1, the answer is just itself. Anything times 1 is itself. But you may not have known it does have a name. It is called the multiplication property of 1. It tells you what happens when you multiply 1. Anything times 1 is just itself. And question 6, here we go. We have t plus 15 plus 0. So this one, again, might make us think, oh, let's get 15 and 0 together in the same group. That way we can add them together. Do we really need to do that, though? No, because if I add 0 to something, it's not changing the value at all. Anything plus 0 is just itself. T plus 15 plus 0, that's just t plus 15. This is another one where we might go, I already knew that. Adding 0 doesn't change anything, but it actually does have a name. It is called the addition property of 0. Tells you what happens when you add 0. Nothing. It just stays itself. So these are just some examples showing you how we can use these properties to simplify expressions, to take things that are a bit longer and shorten them down a little bit.